Good afternoon and welcome to our webinar today on reusing Red Hat Ansible for storage automation. I'm Michael Downs, I'm the CTO for Evolving Solutions, and I appreciate you taking the time with us today to get a better understanding of how Ansible is usable in a storage space. We're really looking forward to it. So our agenda today is we'll have some brief introductions. I'm going to have, we'll go over an overview of automation specifically with Ansible to provide some background for Ansible for folks. And then we'll get into a couple of specific use cases and sort of progressing from some fairly straightforward use cases to something a little bit more complex that hopefully will show an example of what's possible with the technology. So I'm joined today by two folks that I'm very glad to have along. Anuj Tuli is the CTO for Kiva. Kiva is a sister company of Evolving Solutions. Jeff Hecht is the storage consultant here at Evolving Solutions and has done some great work with Ansible and Netapp, as well as a couple of other storage platforms, and is going to provide some content today that I think everybody should find really useful. This webinar is going to be a little bit more technical than some of the webinars we've done in the past. I'm hopeful that you'll be able to give you some content that's useful today that you can go out and do something with. We'll also mention at the end we will be doing a hands-on workshop later in October or the first part of November to get a little bit more hands-on, hands-dirty with Ansible and storage, and would really love to have anyone who's interested join us for that. We should be able to go from showing you some things to giving you an opportunity to actually try some things out yourself at that webinar. So for those of you who don't know Evolving Solutions or Kiva, we're a technology solution provider, and we really help our clients move their data center and their hybrid cloud vision into reality so that we're able to support the business transformation of their organizations. We talked about a couple of things. Obviously, platforms are required to successfully execute any technology, but where we really find ourselves focusing with our clients is around modern operations. So once you've developed a platform, or even if you're just trying to select a platform, how do you successfully operate that new environment? It's not that we've heard from our clients that it's not that the old environments are going away. They still need to successfully operate and maintain those environments. It's that they're adding new environments where they need to support modern development that looks a little bit different than the old style of development, less monolithic, more microservices. And so those capabilities and the things required to be successful in making sure that they're reliable, available, secure, look a little bit different than they have in the past. So automation is a key piece of that. Automation actually provides a benefit in a couple places. One is in your existing environment, it makes things a little bit more, it makes things easier. It reduces the toil, reduces the amount of time your staff spends on, or you spend on doing sort of repetitive manual tasks, and at the same time provides some capabilities that are required in order to do cloud computing, to adopt a hybrid cloud approach, which is becoming what all businesses need in order to be able to be successful. And so that's part of why I'm really excited about our webinar today is we're going to touch on use cases that fit in both sort of a traditional automation of day-to-day tasks and also dive more deeply into some things that you might more likely do in a hybrid cloud environment. So I'm going to turn it over to Anuj Tuli, who's the CTO for Kiva. As I mentioned, Kiva is a sister company of Evolving Solutions. We have the same ownership. We go to work together to provide this overall value to our clients. And I've asked Anuj to walk us through some of the value of Ansible, but also some of the value more specifically of automation in the storage environment. So Anuj, over to you.
Thank you, Michael. So I think, as you pointed out, automation is now becoming a part of not just the application side of things, but also infrastructure. I think we've all heard the term infrastructure as code, and storage obviously plays a key role as well when providing this infrastructure to your application or infrastructure consumers. So what I'm going to do is I'm going to walk through three different points. One is why is automation relevant for storage teams? Then we'll look at why Ansible is a good tool of choice, an orchestrator tool of choice for automation. And then we'll kind of look at some samples of what a playbook looks like. Playbook is a unit of automation within Ansible. So I think the key point here is that even for storage teams, it's not that it may be the case that you're not provisioning too many LUNs, you're not carving out a lot of NFS space, or things that provisioning may not be something that you're doing on a daily basis or something that's taking a lot of time, right? But the key point here is to figure out those tasks that your team members are working on, something that we can automate that produces the highest return. So this could be, like I said, it could be provisioning, but it could be something like remediation of events. So maybe your team gets alerts based on storage disk file full. Maybe you get capacity alerts, and a lot of the time spent by the team is on tasks where you maybe extend the disk, maybe you extend NFS storage. And we'll look at even persistent storage for containers a bit further down. But the idea is to identify tasks that your team is working on day in and day out, where we can produce the most ROI. The other common case we have seen is for self-service. So not only do you want to automate some of the things your team is doing, but now be able to provide the capability for your consumers. Those could be, like I said, infrastructure consumers or application consumers, to be able to come in and make requests, something that you've developed, something that you've approved and blessed from a process perspective, so that your consumers can consume it easily and quickly, right? So that's where self-service integration comes in. And this could be something like integration with ServiceNow or Remedy or something else that you may have. The other common case is about backups and recovery. So, if you have a DR strategy, the idea is to back up maybe you have some on-prem storage and some of your storage is in the cloud, or maybe you're trying to do DR in the cloud. Now, automation would come into play where you are synchronizing your on-prem storage clusters with off-prem, and primarily when you want to recover. So let's say DR happens, or maybe you're doing some testing for yearly failovers and things like that. You want to be able to automatically now pick up or have the storage clusters available in the cloud as functioning, or maybe you want to bring back the images that you may have off-prem back on-prem. Again, depends on your architecture, but it's primarily geared towards a hybrid scenario where you have storage on-prem and off-prem. Similarly, the failover failback, the difference here is that failover failback is more for, let's say you have an active passive cluster. So you have a primary cluster and you have a secondary cluster, and either primary goes down or you want to do some maintenance. You want to be able to fail over to the secondary and maybe even replicate some of the policies, because in your current scenario, let's say you have primary on-prem and secondary off-prem, you have these synchronization policies that are replicating data back and forth. So those policies will now have to be switched, as an example, right? So now you make secondary or primary and you want to flip the policies and so on, right? So there could be automated scripts you want to kick off. These could be based on manual triggers. These could be based on automated triggers. So there's plenty of automation you can build around that use case. The upgrades, patches, and fixes. We'll talk a bit more about this later in this discussion, but we'll kind of go through an example of what that means. Let's say you have storage clusters that are using a version that may be off from what the vendor is providing by 2 or 3 releases, and you want to automatically upgrade the versions of your cluster. That's the use case that we'll discuss a bit more later. For clients who are already down the path of containers, right? Let's say you have a mature container strategy and your application is supposed to use persistent storage on nodes, specific nodes. Let's say you have Kubernetes nodes that are hosting some applications that require context to be preserved, or maybe they use some data that's geographically sensitive or relevant. So for those cases, when you are pushing applications via your CI/CD pipeline, you also want to keep care of making sure that the storage available on particular nodes for containers is also present or available or created if needed. And then I think we've all gone through and heard about reduction of manual errors, and it's very, very important to stress, but it's also the most commonly identified benefits of automation in general, more so than storage automation. So So the idea here is to make sure that the teams identify the tasks that you all are working on day in and day out repeatedly, something that we can automate to produce the highest ROI. Next slide, please. Okay, so then we look at why Ansible. And apart from some of the things I've mentioned here, again, it's, and we'll kind of look at a demo as well. We'll look at what a playbook looks like as well. Ansible provides the ability to not only bake your infrastructure as code pipeline, but also provide drift remediation. So there's this entire aspect of configuration management that Ansible provides that I would say, Ansible would be, I would call it the de facto standard when it comes to configuration management nowadays, right? Especially in the era of DevOps and the pipelines that we live in. So number one advantage is it's open source. And I think we know that it's open source, anybody can download it, anybody can use it. But the benefit that Red Hat provides on top is they have a commercially supported version available as well called Ansible Tower. The feature set available in open source is almost the same as on Tower, except when Tower has some additional benefits like RBAC and clustering and all those things. But for you to get started in automating some of the remediation workflows that we talked about, or you want to automate provisioning workflows, all those can be done using the open source, the community version. It's easy to learn and use, and we'll look at how easy it is in one of the next slides. And no programming necessary. It's YAML based, so it's basically defining, if you're familiar with XML, YAML is similar to XML in where you define what the parameters are going to be and what the structure is going to be. And Ansible is going to take care of making sure that your end goal is achieved. It's agentless, so no agents required, no maintenance of agents, no upgrades of agents, no ports to be opened as such, specifically for agents. It's idempotent, and what this means is, let's say you create a playbook to restart a service, right? And you run that playbook multiple times, the restart of service will only happen once. In other words, Ansible will make sure that if the service is not started, it will start it, but if the service is already running, it won't touch it, right? So the idea is you can run the same task again and again without the risk of causing any issues. The community size and support, again, if you look at GitHub, it's one of the most liked and most downloaded pieces of open source software out there. We also have access to a Forrester report where they define they have specific metrics around what a community size and support it would look like, and Ansible received 5 out of 5, which is the highest rating. So it's a very strong community, a lot of developers, a lot of contributors that put back into the software, and also the ecosystem surrounding the software. So if you look at why it's the integral part of CI/CD pipelines is because the community keeps on developing new integrations, new connectors to Ansible, such that regardless of where you call Ansible from, as long as Ansible is your orchestration tool of choice, you can integrate it with your existing pipelines, you can integrate it with something else, even Terraform, right? So there's integrations between anything else out there with Ansible. So it's very widely adopted. Next slide, please. So what does this playbook look like, right? We all hear about Ansible playbooks. Here's an example of an Ansible playbook. So as you can see, you can actually read the playbook and kind of understand what it's doing. So if you look at the first section of it, it's running against web servers, which is a group, let's call it a logical group of target systems. And you log into those logical group of target systems as root. And then what you're doing is you're making sure the HTTPD, which is a web server, is the latest version. Similarly, if you look at the second part at the bottom, it's running against a logical group of database servers, and it's making sure that PostgreSQL is the latest version. And then we'll break this down into further components, but the idea is just looking at the playbook. If you're familiar with development on Java and .NET, there's no loops, there's no conditions, there's no methods, there's no inheritance. I mean, there are these concepts that apply to Ansible, but you don't have to program anything. It's basically writing these name value pairs, if you will, in a specific structured format. The next slide, please. So this is where we break this down, right? And we can look at, by the way, these separate components are called plays, and a plays run against a given set of systems. And like I said, this is a logical set of systems, web servers, databases that we are running this against. And you can have multiple plays in a playbook. So think about the case where you want to take different steps as part of your workflow, and you want to run these different steps against different endpoints. And it doesn't always have to go to the same sort of logical endpoint either. So what I mean by that is you can choose to create multiple playbooks, or you can choose to have multiple plays within the same playbook. It really depends on the architecture for automation that you're setting up. But the idea is to differentiate or create different portions based on the function you're running, right? So again, very easy to understand, very easy to modify. So if I am a sysadmin and I come in and I have no programming skills, I can look at this and say, oh, maybe I want to make sure that when the database pieces run, the database plays run, I don't want PostgreSQL to be started. I want it to be stopped, meaning I don't want the database service to be running. I would just come in here and change the state to stop, and that's it, right? So it's very easy to understand, very easy to modify. And so no specific skills needed per se from a programming standpoint. Next slide, please. So now we break a play down even further. A play has different tasks within it, right? So a task, as you can see here, the first task is an application of the latest version of web server using yum command, right? So it's similar to if you were to go on a Linux box and type in yum HTTPD latest, whatever, right? So you're using yum to download the latest bits of HTTPD on that system and applying it on that system. So, so again, you can have multiple tasks in a play. The second task there is it's using something called Jinja templates, and we won't get into it today, but you can essentially have a config file defined, a config template defined with a number of variables, such that those variables get populated at runtime and get applied at runtime. So if you look at SRC, the source file, it's a .j2 extension, it's a Jinja extension, and that file essentially has variables within the template so that when you apply it at the destination, you could potentially read it from an environment variable, you can read it from another, you can read it via a variable that you pass to the playbook. It's not done in this case, but just to give you an idea that you can have parameters that get passed in real time and get applied in real time. Next slide, please. Okay, so we break it down even further. So there's these things called Ansible modules. And so yum is a module, template is a module. If you look at the bottom, service is a module. And what a module is basically a granular function abstracted away from the user, from us, from what it does on the backend. So if you think about it this way, when you say service :name and then state, we don't care how Ansible makes sure that PostgreSQL service is started, but Ansible does it on the backend. It's the module that actually uses code to do it for us. So from a Ansible user perspective, if I'm the user writing playbooks, I don't need to worry about the command line. I don't need to worry about API calls. I don't need to worry about anything, right? All I need to know is what is the format to pass along the arguments to my module, to my my instance of the module, right? So that's what that kind of shows. So there's an Ansible has thousands of modules. Specifically around storage, it has again hundreds of modules, and Netapp actually has the highest number of modules when we look at the storage side of things. But again, even we can develop our own modules. In fact, Eva has developed our own modules whereby you want to talk to, say, for example, ServiceNow. You don't need to worry about ServiceNow APIs. All you do is provide information in a specific format, and it'll create a ticket or do whatever, right? So the module provides different functions. So anyway, we are going to look at, today we're going to look at some of how we can potentially use some of these modules like the ones available via Netapp. And Jeff's going to walk us through a couple of demos for that. And so I'll hand it over to Jeff.
Grab control here. Hello, everybody. The two sets of playbooks that we're going to be running through here. First one just involves an ONTAP select deployment. Could be done with a physical Netapp appliance as well, but essentially the setup is right now the two virtual machines have been deployed with the base config, cluster IP address, node IP address, and then the internal cluster IP addresses, as well as some VM disks deployed. So we're sitting at a base config. This wouldn't be any different than when you were ready to start actually physically connecting to the ONTAP cluster and getting it going. So the tasks on the right side with setting NTP, time zone, et cetera, all the way down through auto support there, all of those tasks are done in line in this playbook that we've got here. And all of them they take roughly a little over a minute to get done. Comparatively, when you run through and we're trying to configure all these manually, or like we've historically done, a script, we'll call it, of commands that we run to go through and configure the broadcast domain and break up, remove the individual ports and create the interface groups. So as we go through and configure the Netapp, we've got a lot of opportunities for not only fat fingering problems, but also if something doesn't go right down the chain, we have to kind of backtrack to get to the point where we want to continue moving forward. So a big benefit that we found along the way is if we make a mistake, and I'll show you one here as we go along, the playbook will fail. I'll have the opportunity to update. It'll go through and validate the configs up above that in the playbook are already completed, and just move forward to the next one. And basically we'll get back to the point where we failed, it'll validate it's okay, and it'll continue on the config. So that's pretty powerful in our mind, where we not only don't have to go through and modify 40 entries of a particular cluster name or an interface name, we just do it once in a variable. And just like any other variable, we because we're not hard coding it, we have the benefit of and the nicety of actually being able to just continue moving forward. So, Michael, can you hand me the ball, please?
Magic ball. There you go. So just while Jeff's pulling up his demo here, I would just share with everybody, I neglected to mention this at the beginning, that if you have questions, please feel free to post them in the Q&A, and Anuj or Jeff or I will try to pick them up and see if we can answer that for you. And I will looks like Jeff's ready to go.
So just a little background. ONTAP select deployment has two virtual machines running. I have the cluster up and running, and I've created an Ansible user account that we'll be using. And for those of you who don't want to see the password, look away because it's right there in the script. I know we can probably get the, we'll have Anuj talk about the ways in which you can hide the password or not provide it in clear text. I did not bother to go down that route for my particular script here, but the variables that we're putting into play, and what I mentioned was, we're just defining the list of things that we want done, right? So from a cluster name, we know that this is the cluster name that already exists. The nodes already exist. Those are based on the other modules that we're going to be running along the way. So when we're creating an aggregate, we know we want that one to be on node 1. So there will be some looping in here that shows, for each one of these nodes, I want this particular setting applied or this aggregate named, as well as different volumes, different interfaces, and different interface groups created along the way. Just that, like I had mentioned, I did create an Ansible account. This script that I'm using is from sysadmin tutorials on GitHub, and a lot of it is from there. So, you know, if you have the ability to create a ONTAP select cluster and you have some time to tinker around with different settings that you want to do along the way, you can do this as well at home. So without further ado, I'm going to go ahead and click go here, and then we'll kind of step through it as we go. I'll watch it in the system manager here to watch things get and
Jeff, if I can just quickly add, so if you look at, I'm sorry, if you look at command, that's the module that we were talking about, right? That's available via Netapp on Ansible. So that's a module that Netapp makes available. So we are just leveraging the module, making sure we are passing the right arguments. And then just quickly before Jeff, you take it back, there was a question about what's the best way or best practices around credential management and encryption. So, and you also asked this question, Jeff, and there's something called Vault. And you're not planning to cover it here today, but there's something called Vault. You can search for Ansible-Vault. And what it allows you to do is you can encrypt passwords within a file. You can encrypt the entire file itself. And then if you're using something like Ansible Tower, you can pass the encrypted file as an argument. So then you only have to define the password once or encrypt it once, and then you can leverage that encrypted password or the encrypted file across various playbooks, not just one playbook, various playbooks. So there's different ways to encrypt it. Ansible provides these tools out of the box, but we don't plan on covering here, but that's usually how clients do it. Sorry, back to you.
Thanks, Anush. One thing I did want to note too, that there's a module here called NA-ONTAP command where you can actually write out the command that you'd be using in Netapp. Those are for modules that could still be in development or they haven't had the opportunity to build out yet. So you have the ability to actually run, if I was at the Netapp command line, I would run cluster date, modify time zone, etc. That's the command, and you have the ability and the flexibility to do this as well. And you see from a privilege standpoint, you can actually elevate if that was needed as well to get those things done. So I'll go ahead and run it and we'll find my failure and then we will show how this thing continues on. So we're all waiting patiently here as it logs in.
So I mentioned that we'll be hosting a more hands-on workshop towards the beginning of November. That's the kind of thing where we can certainly dive in a little bit deeper around things like credential management. Also, are offering these kinds of workshops individually for clients as well. So if that's something that you have a specific use case in your environment that you want to dig into, to both automate that use case and maybe get some specific best practices for your environment, we'd be happy to do that as well.
So the example that I used here, I just have the incorrect character there for the name of node 2. So after a quick save and rerun, we'll see that in the system manager interface, I have one data aggregate created based on what I had in the script here with agr1 n1 on node 1. So it failed on node 2 creating this second aggregate just because the name was incorrect. So that'll follow down all the way through the rest of the script now that I have the name corrected. So we will continue on, and what you'll see when we get to the first aggregate creation is it'll just throw an OK flag up, and then it'll continue on its way to create the second one. So you've got, now we're creating an SVM after the aggregate was created, specifying protocols we have in place. Now it's going through and adding the different network broadcast domain, or removing broadcast domain ports so that we can create the interface groups, create the VLAN. Sorry. You can see we've created our interface group there, and on node 2 as well. So now we're just creating VLANs. We're going to continue on the configuration here as we continue through. A couple nice things that you could actually have along the way is, once you have it built out, if you wanted to add in additional storage virtual machines, right, that the ability to take this exact same playbook, add on to the end of it and say, I want to add in another storage virtual machine with these interfaces and these volumes on the base config, those can all be added in and then rerun, so that you have the opportunity then to say, I know that this is the config of my NetApp. If I have any questions, or if I want to redeploy, or if something happens along the way, I can just reference this playbook and know the exact set of variables used to configure it, as well as a way to redeploy it if needed in the future. So you see that we've created storage virtual machine, we've added NFS, we've started NFS, we've created the export policy for us to be able to access, and then we've created the first volumes using that same export policy, so that essentially when this script is done running, we are ready to add it to whatever we're doing. So if we're adding it to VMware, if we're having NFS mounts added to Linux hosts, all of that is ready to go as soon as this thing is all done. And in the amount of time it took me to fail and restart, probably a matter of 3 minutes or so, we've got a NetApp appliance up and running with volumes, with a set of interfaces, interface groups, broadcast domain can changes so that we have it specifically for the way we want it, and it's ready to go. So it's a very powerful tool in that sense. Like I said, the way we've typically done configs would take a bit longer, because we're running the command, we're hitting enter, we're waiting for it, we're checking it, we're going, doing our the motions for each command along the way, as opposed to fully automating the deployment, which is actually pretty powerful in my mind.
Absolutely.
All right. Michael, do you want to take it back so we can start talking about the next one? And I'll do a wardrobe change real quick here.
Wardrobe change, all right.
Yeah.
Fantastic. See if I can do that. I think you've got to give it back to me.
Yep.
All right. Share. Go. All right. I will. There we go. This is our next example. And Jeff, did you want to talk to the architecture here?
Yep. So in our lab, was that Michael?
I think you're quiet there, but I think you're okay. So.
Okay. In our lab environment, we have the SQL Server. I've used the database here, putting it on iSCSI LUNs and using a different ONTAP select deployment, and having that mirrored from local to Azure, and a Cloud Volumes ONTAP instance out there, as well as a virtual machine in Azure running SQL, not any sort of platform as a service SQL, just a standard Windows virtual machine. So what this process is going to do is it's going to reach out to each one of these servers and NetApp ONTAP selects and perform different tasks. And we've talked about the different modules in play here from the NetApp standpoint. There's a whole lot of them, but there's also some in the Windows world that we're leveraging here along the way too, from Windows Shell, Win Command, and then Win Service as well, because the process is going to require a little bit of back and forth between the on-prem SQL Server as well as the Azure SQL instance, and then a little bit of replication and communication between the arrays as well. So as we work through this process, it's going to be doing commands at different layers, along with even in the SQL Server on the on-prem side will be injecting a date timestamp saying this is the last time it's been refreshed, and we'll do a validation when we get up into the Azure IaaS implementation there to show that same timestamp is flagged and we've actually got the latest data replicated. I am in this example stopping SQL Service on the on-prem, and I know that probably there are plenty of other ways to accomplish that, but again, for trying to work through here, just to get a clean quiesced copy of the database, I just powered or stopped the SQL Service in this example. All right, Michael, I think we should be good to move on to the next one. Thank you. So this is just kind of a workflow of how the playbook works through the data refresh out in Azure. A couple things to note here. When we go do the Azure Cloud Volumes on Tap swim lane there, when we go to unmap, we're actually, again, issuing commands from Ansible into Windows to say, I want the drives taken offline. I'm sorry, the Azure VM there. We're taking the volumes offline through Win command. We are then going to Cloud Volumes on Tap and actually removing the mappings. And then we, recreating the snapshots and mapping them back up. So these are the commands that we're running here across all of the different systems in play here. So it does give you an example of just the flexibility of what Ansible can provide. And you could do, Linux hosts just by SSH there as well. So it is a very powerful tool to be able to get a significant workflow done in a pretty short amount of time as well, as opposed to if you had to click through each one of these and get them done, I think it would take you quite a bit longer as well as there's the risk of fat fingering something or accidentally doing something you shouldn't be doing in the first place. So I'll take control back now, Michael, and we'll walk through the second example.
It should be coming your way.
Thank you.
Again, I feel free to, if you've got questions on this or whatever else, please feel free to let us know. Happy to help however we can.
And a little shameless, a little plug here for Visual Studio Code is a pretty powerful tool. I've been doing a lot of this development, PowerShell scripting as well. In this instance, I'm actually in VS Code connected to that application host, the Ansible host via SSH in Windows using VS Code to do this. So it's actually, I don't know, I thought it was kind of neat. So as we look at the environment here, let me pull up the two SQL servers. We can kind of walk through and see how this steps through the different processes. But if we look at the playbook here, what we're doing, as far as the detached database, the check database, we're actually just issuing, commands in Windows Shell on those hosts. And when I built out the script, I have host groups defined in a separate answer file, which also has the password stored in it as well. So that's why you're not seeing those Windows passwords and those credentials passed here as well. So those are kind of hidden. The Netapp ones are still in play here in this particular script. When we go to do the, even the insert refresh info, so when we add that timestamp into the latest, we're still doing the SQL commands. As Anuj talked about with the services, we just say the state is now stopped for the service name we're looking for. And then, as we look into the Azure world on that particular virtual machine, we know the iSCSI node address. We're taking off the disks that we know are the ones that are mapped LUNs. And then we are setting disks offline, disconnecting from the iSCSI, and then we're doing the Netapp work. Netapp work basically is just saying I want to take a snapshot after I've stopped SQL of the source side, make sure we clean up all of the other clone volumes and LUNs that are on the Azure Cloud Volumes on Tap, kicking off a replication, make sure that snapshot gets replicated over to the other side, creating a new clone once we have it on the other side, and then mapping that up to that Azure guest. And then once we get the data there, we're all the way at the bottom of the script, we are going to reconnect the drives, and then we're just creating a new version of the database, attaching the files that we have specified where those data and log files exist. And that's basically the extent of the script. And kind of the reason I went this route is we've talked a lot about hybrid cloud. We've talked about use cases for Netapp's data fabric to be able to leverage some of that to get that workload out there. And even from a if this is your reporting environment, for example, you've got the ability to just shut this down when you're not doing your reporting, bring it back up, do the refresh, do your thing, and then spin it back down again. So you have that ability to use and leverage those resources out in the cloud and in a cost-effective way. And your data is not stuck there. It's on NetApp, so you can bring it back out if you need.
Great points.
Go ahead and kick it off.
So while you kick it off, I just want to quickly add that you just triggered this via a command line, but this could be scheduled as well. You can trigger it externally. You could trigger it via, if you have Ansible Tower, it provides REST APIs. You can trigger it via REST APIs. So while we are doing this on the command line right now, there's multiple ways to trigger it and passing variables when you trigger it as well.
So we'll see the disks going offline here as part of this process. We'll disconnect the iSCSI targets. All the disk will go away at that point. And then on the NetApp side, so I did build in some 15-second timeouts here just to make sure we got the latest snapshot replicated. And again, you could use the NA on tap command to check for the presence of it. There's a module in place too for NetApp SnapMirror. But as far as just the data that we're replicating and the timing involved, 15 seconds was plenty for us to get the data up there of the newest copy. So now that it's gone through and created the clone and mapping the LUNs, it's starting the SQL service again on the on-prem side, and it's going through and attaching the LUNs in Azure, and then it will do the database creation, attach SQL database, and it has completed. So just as a show me what we did, if we look at the bottom here, we were saying 10:43. Obviously, my time is off on that particular server, but 10:43:14 is the date timestamp on that server. The latest refresh, and give me a moment while I can validate that the same timestamp exists on the destination side too.
So Jeff, on your which modules did you use from NetApp to set this up?
So this one has NA on tap snapshot, NA on tap volume, LUN map, tap LUN map. I have the NA on tap command as well.
Okay.
Volume
then
clone.
You mentioned a couple of other.
Was that
I mentioned a couple of other modules as well that were non-NetApp modules.
Yep. So when we look at the Azure Win side, we're doing Win command. That's just executing Windows commands. There's Win shell as well to do the invoke SQL commands. I tried to do the Win command with the invoke SQL, and I needed to do more investigation to see why I couldn't standardize them one or the other. But one works one way and the other works the other way. So that's just kind of where I ended it. And then the Win service was the other one where I'm starting and stopping the SQL service on the on-prem SQL instance.
Awesome.
And then it says in recovery here, so we'll just refresh it.
And so I know that Netapp has the sort of certified their modules. I think that's the right terminology, because they were trying to make sure that I know it, because Ansible is so easy to use and you can contribute whatever. A lot of people had written different things to do different ways, but Netapp chose to sort of create some standard ones. Is that, am I stating that properly?
Yep, absolutely. And so you can see we've got the same timestamp 104314 on the Azure side, so we know that we've got the latest copy. We've got a good clean cut so that we can continue doing whatever the work is on the Azure side of the world. So yeah, Michael, the idea that, you know, Azure has all these certified modules, they're continuing to develop them, and they're watching, specifically from what I've heard, that instance when I use the NA-ONTAP command, they watch those, they keep track of that flag through auto support to say, if this is used enough, we have to figure out a way to actually create a module for that so that the ONTAP command can be used less frequently, right? And especially you look at the elevation requirement too, right? So you don't want to necessarily elevate to an advanced or a diag personality when you're trying to run these commands either. So trying to streamline that so you don't need to change back and forth is a good thing as well.
Awesome. All right, pass it back to me, and just wanted to wrap up with an example of what I would call a little bit more complex use case that, there we go, a little more complex use case around updating a Netapp cluster. And maybe, Jeff, if you want to sort of walk through the use case and you provide a little color commentary on how we might do this. So.
Yeah, the struggle that we've got right now, and Anuj alluded to it earlier, is when you have clients or when you have Netapp instances that are 1, 2, 3 versions behind, getting those updated and going through doing that manually each time is kind of painful. I know you're still going to want to know what's going on, the notifications involved, the IT service workflow as well, change requests, etc. So you want to make sure you have the ability to go through, do that, but you also, there's always been a struggle in my mind. I have to have a web server in place for all of my disk firmware, for all of my shelf firmware, disk qualification packages, if you have to push out a new service processor instance or firmware update as well. Those types of things, they're not necessarily something you do every day, number one. Number two, it's kind of another web server you need to keep around for a single use case. So kind of the brainchild here is we have a solution. We can use Ansible to do the ONTAP upgrades. We have a way via containers to do a web host, for example, that you can build up, get everything on it, and tear it down afterwards. And Anuj, do you want to talk at all about the container web use case there as well?
That's exactly it, right? I mean, you can have Ansible be that glue that spins up that container, or even if it's a VM, it's the same thing from an API perspective per se. But the idea would be to spin up the container on demand when needed, and it can be hosted on your existing VM on a Windows or a Unix platform. It connects to your ActiveIQ. It connects to your Netapp portal, downloads the latest bits, and then that small container can serve as a web server temporarily until all those fixes, all those patches are applied to your storage clusters, and then it goes away, right? And you can choose to have storage that could be persistent, where the container comes out as a CPU unit, downloads these patches, puts it on your NFS share or whatever, and then goes away. And then next time it needs to be spun up again, it looks at what's out there, what's been downloaded, so it doesn't have to download again. So the idea is you can have that entire logic baked into the Ansible Playbook, and depending on where you left last, what patches you have downloaded, you then download only the differences and apply those differences to your clusters.
And then, as always, we've got to make sure patches get applied correctly. So we have the ability using Ansible to actually monitor, to keep track of what's going on, so that we can check on it occasionally, and we don't need to have eyes on it all the time. Now, there might still people that want to, and that certainly is available too, so you can kind of watch that go in the background. But when we have multiple clusters in multiple locations, and you want to kind of go ahead and kind of roll this out, and Anuj even mentioned it earlier, these playbooks don't need to be triggered manually, right? So you could have them through a ServiceNow, or you could have them through another tool set that says, hey, I want to run patches and I want to be notified when they kick off, status on a regular basis, and then I want you to tell me in the end what happened. So you don't necessarily have to be hands-on for the entire process as well. So we think that's kind of a differentiator here, and I think it's kind of a good solution for those, even if it is a small environment, but you can actually, number one, again, that web host that you have to maintain, keep track of, what patches are on it. Next time you roll around 6 months from now to do the updates, what was the server name again? Where did I keep all the patches? All of those things you don't need to keep track of anymore. And we think that's a big win.
Yeah, and I really love this use case too, because it does illustrate sort of both traditional, I need to update a storage array that's in my data center. I can use the next generation technology around containers to potentially hold, always get the most current version of the HTTP server when I pull that container down to set up my environment. This is a great example in my mind of modern operations and why automation is such a critical piece of it. It allows you to do both. You both get better at what you've always done before, and you can take advantage of some of those things that are quote unquote modern application approach to building out things in the data center. Any other comments on this, Jeff or Anuj?
Not for me, Michael.
No, all good.
All right. Well, thank you everybody for joining us today. I really appreciate it. Hopefully you found this useful. Hopefully you've learned something. We'll send this out afterwards as well. Here's some links that the Netapp modules, as well as just the general Ansible. There's a tremendous number of modules out there for Ansible. As Anuj mentioned, there's always the possibility of building new modules. That's something that we've done for a number of clients in order to make their work easier, and I'm happy to work with other clients to make that happen as well. I mentioned earlier we're going to be doing a virtual hands-on workshop, so we will be sending, if you're interested, go ahead and send an email to info@evolvingsol.com. We'll have a registration link out and available in the next several days, and we absolutely look forward to hosting you for that. Anuj and Jeff, thank you very much. I thought this was really great content. Thank you everyone for joining us today, and we look forward to talking to you all soon. Have a great afternoon.